Okay, this is the first question of this assessment. So it's a game. It's a game of cards. It's called Game of Eights, and you have the rules here. Um, the first question is to create a contract. No, is to use the contract that is given here to create a sequence diagram for the createPlayer contract. So we also have the domain model, and basically the contract tells us exactly what changes to our object should be like. So just to roll back a little bit, these contracts come from a particular use case. We are not given the use cases here. We don't really need the use cases. But in real life, it would come from a use case. It would come from a system sequence diagram, and one of the events generated by a player would be to create, to start the game, and would be to create a new player. So one of the events received by the system from the GUI would be create player name, and that is the event received by the system. Somebody else has written the contract here. We'll only focus on the post condition. Okay. Somebody else has written that contract, and we basically have to create an algorithm that respects this contract. So it's the name of the event is createPlayer, so that's going to be the name of our method. It has an argument, the name, which is presumably a string, but that is a detail. And what we have to do is to create a player, P, set its name to the argument that is given, and also to associate this new object that has been created, this instance, P of type player, with 8s. So we just have to have a look to see if that makes sense as far as our domain model is concerned. We have to create a player, set its name, so the argument does exist, and just create this association. So 8s needs to know about the player. That's all this event should do in terms of your object, and therefore we need to create an algorithm for a method of the same name which does exactly this. Okay, so we need to create a sequence diagram. So let's switch to the sequence palette in UMLet, or whatever tool you wish to use. The first thing that we have to worry about is, since it's a contract, is which instance will receive this particular event. Okay, the event that we have, okay, at the moment is called createPlayer with a name as an argument. So it's going to be received by an object this way, and we can set the name. It's called createPlayer with a name as argument that is given exactly in the contract. And really our first question, and that is very important, is to answer properly, is what instance is this? What is the instance from the domain model that will receive this event and actually implement, fulfill the contract? So it has to be an object from this selection here. It can't be player, because obviously player doesn't exist yet. That is the purpose of this createPlayer contract, is to create the player. Okay, the player does not exist. It's even written there. That's quite a lot of detail here, which in real life would not be given. Okay, but it's just to make it as easy as possible. So the player doesn't exist, so player cannot be the controller for this particular system event. So we have, and in effect it could be any other object that already exists, okay, but we need one that actually makes sense. Okay, so in the contract it says that the player needs to be created, and that player that is created needs to be associated with 8s. So it seems to me that the most logical way that is to decide that 8s, since there's a game already on the way, or the game has been initialized, that 8s will be the object that controls this particular system event, and in fact it will be the controller for all the system events. It's a relatively simple game. All the events will be handled by the same controller object. Okay, we could imagine all the GUI events handled by the same instance 8, or which is only going to be 1. That's going to be our simplest choice. And here it really makes sense because 8 is going to create this instance and then gets associated with it. Okay, so we need to translate this into an algorithm, and we use a sequence diagram for that. So we've decided that this instance is actually the instance of 8. Okay, and we need to decide what happens next. According to the contract, what should happen next is that we need to create a player. Okay, so creating instances is something that we do all of the time. Okay, obviously in code or during design. So it's relatively simple. We create the new instance by doing this. It's a player instance we're going to create. We could call it P because it's called P in the contract, but we won't refer back to it again, so there's no need to call it P in the diagram. Okay, and in UML, the way we do this is we say that what createPlayer will do is to create this instance, and in UML the keyword for calling the constructor is not new, it's simply create. Okay, now if you call it new, I don't mind. Okay, it's really a detail. But we also put in the arrow onto the box itself, onto the instance itself. So that is a short notation for saying, and we don't need this line, for saying call the constructor of player. We pass on the argument at the same time, so you know we don't need to explicitly say p.name was set to name, because otherwise that goes into too much detail. And that's the advantage of using a sequence diagram, is that you know if a programmer sees this, he knows what to do with the name. He just needs to set player.name to the name. Okay. The other thing that is implicit in this notation is that obviously the constructor returns a reference to the object created. Constructors do that, otherwise it would make absolutely no sense whatsoever, whether in code or in UML. So we don't actually need to show that a reference is returned, and we don't actually need to say that 8 keeps that reference. Okay, so in code we would have to detail this a little bit more, but the advantage of using this notation in UML is that this is all we need. We've decided who the constructor, the controller is, it's 8. So createPlayer and events from the GUI, okay, is handled by 8, and pass on the argument name as per this. Okay, that's how your diagram should start. And then this method createPlayer of 8, then just call the constructor of player, passing on the name. So p.name will be set to name by the constructor, and whatever other details. Here there's no other details, but sometimes constructing objects is more complex than this. It's very simple here. So that creates a player, and the player will be associated with 8, and again that's implicit here because constructors always return references to the object you've just created, and here implicitly 8 will keep that reference to itself. Okay, so that player 8 will now know about a player instance, and that's all there is to this particular sequence diagram. It's a very basic algorithm. It cannot really be more simple than this in terms of a sequence diagram. Okay, in a minute we'll move on to the other one, which is a little bit more interesting.